Welcome to aminacademy.com. In Fourier series, let us discuss about Parseval's identity. In mathematical analysis, Parseval's identity, named after Marc-Antoine Parseval, is a fundamental result on the summability of the Fourier series of a function. Geometrically, it is a generalized Pythagorean theorem for inner product spaces, which can have an uncountable infinity of basis vectors. Further, let us discuss further about Parseval's identity. Assuming that the Fourier series corresponding to f of x converges uniformly to f of x in limits minus L to L, then we can prove the Parseval's identity. Now look at here, Parseval's identity you can write as 1 over L minus L to L f of x the square dx, which is equal a0 square over 2 plus sigma n equal to 1 to infinity a1 square plus b1 square. The Parseval identity for limits minus L to L and f of x converges uniformly to f of x. Now, where this integral is assumed to exist. So, integral is assumed to exist, then it's a Parseval identity. Now, let us prove it. If f of x equal a0 by 2, this is a Fourier series, general Fourier series, plus sigma n equal to 1 to infinity an cos n by x by L plus bn sin n by x by L. This is a Fourier expansion, Fourier series. Then multiplying by f of x and integrating times by m. Now we are multiplying by f of x. We have integral minus L to L f of x the square, because f of x is multiplied with f of x, this f of x square dx equal a0 by 2 integral minus L to L f of x dx. Then plus sigma n equal to 1 to infinity an integral minus L to L f of x cos n pi x by L dx plus bn integral minus L to L f of x sin n pi x by L dx. Look at here. Then we wrote the series, which is equal, after integrating and put the values of minus L to plus L, we have a0 square over 2L plus L into sigma n equal to 1 to infinity an square plus bn square, where we have used the result. Look at here. minus L to L f of x cos x n pi cos of n pi x cos of n pi x over L dx is equal L an, that we are using that above result and comparing, and further minus L to L f of x sine n pi x by L dx equal LBN, and next is minus L to L f of x dx equal L a0. So we compared and obtained from the Fourier coefficient. This obtained from the Fourier coefficient. Okay. Fourier coefficients. Now the required result follows, and dividing both sides of the equation by L, the Parseval's identity is valid. That means it under less restrictive conditions than imposed here. This is a proof for Parseval's identity here. Now let us do some example problem regarding Parseval's identity. Write Parseval's identity corresponding to the Fourier series of f of x equal to x, that is 0 to 2, in a half range of cosine series. Now look at here. L equal to here, L equal to 2, A0 equal to 2, and AN equal 4 over n square pi square cos of nx minus 1, where n is not equal to 0 and bn equal to 0. Therefore, the Parseval's identity becomes Parseval's identity is equal half of integral minus 2 to 2, because here L is 2 and f of x the whole square dx, which is equal half minus 2 to 2 f square dx, which is further equal 2 squared by 2, that is a squared by 2, plus sigma n equal to 1 to infinity 16, because we are using x equal to pi power 4 and pi power 4 cos of n pi minus 1 the square. After simplifying, we get or 8 by 3 or the series is equal 1 by 1 power 4 plus 1 by 2 power 4 plus 1 by 3 power 4. Like here, we split this as the series as 1 power 4 plus odd additions 1 by 3 power 4 plus 1 by 5 power 4 plus even addition is 1 by 2 power 4, 1 by 4 power 4, 1 by 6 power 4, like here. From this we can get it, that is you can say 1 by 1 power 4 plus 1 by 3 power 4 plus 1 by 6 power 4, which gives 5 power 4 over 96 by using these calculations. That is, now we got the series that we have to find cosine series of half-range function of Fourier series. Then next part of the question. Now in general, you can determine the sum of s of the series, that is 1 to full series. We can get it, this one is equal 1 by 1 power 4, 1 by 3 power plus 1 by 6 power 4, 5 power 4, sorry, 5 power 4 going plus 1 by 2 power 4 plus 1 by 4 power 4 plus 1 by 6 power 4, like its extent, which is equal 1 by 1 power 4 plus 1 by 3 power 4, 1 by 5 power 4. Here 1 by 2 power 4 we can get it out, the common 1 by 2 power 4 is 1 by 1 power 4 plus 1 by 2 power 4 plus 1 by 6 power 4, 3 power 4, sorry, 3 power 4, because 6 is 2 into 3. Therefore, which is further equal 5 by 4 plus 96 in previous result. This one plus s over 16. 2 power 4 is 16. So this is s. So s over 16. Hence the result there is equal to 5 by 4 plus 96. We have done. Please subscribe our YouTube channel.